Okay, so uh, our topic of today is the solar system, and under the solar system, we are going to talk about different things. So our introduction talks about the sun, moons, and stars are commonly referred to as heavenly bodies. The earth, the heavenly bodies, and the sky make up the universe. The universe has stars, and a cluster of stars is known as a galaxy with with each containing many stars. Our galaxy in which the solar system exists is the Milky Way. So the solar system. And here you are going to look at the definitions and different types of planets. So the solar system refers to the grouping of heavenly bodies comprising the sun and 9 planets. The sun is a star around which the planets and other heavenly bodies revolve. The solar system comprises the sun and the objects that orbit it, where they orbit it directly or orbiting other objects that orbit the sun directly. The largest 8 are the planets that form the planetary system. The solar system formed 4.6 billion years ago from gravitational collapse of a giant molecular cloud. The vast majority of the system's mass is the sun, with the remaining containing Jupiter. The 4 smaller inner planets, Mercury, Venus, Earth, and Mars, are also called the terrestrial planet and are primarily composed of rocks and metal. The 4 outer planets, the giant planets, are substantially more massive than the terrestrials. The two largest, uh, the gas giants, Jupiter and Saturn, are composed mainly of the hydrogen and helium, uh, which are the two outermost planets. The ice giants, Uranus and Neptune, are composed largely of substances with relatively high melting points compared with hydrogen and helium, called ices such as water, ammonia, and methane. The solar system also contains regions populated by smaller objects. The asteroid belt, which lies between Mars and Jupiter, mostly contain objects composed of the rocks and metal like the terrestrial planets. Beyond Neptune's orbit lies the Kuiper belt and scattered disk-linked populations of Transneptunian objects composed mostly of ices. Within this population and several dozens to more than 10,000 objects that may be large enough to have been rounded by their gravity. Such objects are referred to as dwarf planets. Our solar system is located in the Orion arm of the Milky Way galaxy. There are more likely billions of other solar systems in our galaxy. So let's also look at the formation of the solar system. Our solar system evolved from a thick cloud of interstellar gas and dust some 4.5 billion years ago. The cloud imploded, probably as a result of the shockwave from a nearby exploding star known as a supernova. When this dust cloud disintegrated, it created a solar nebula, which is a spinning, swirling disk of material. Gravity drew more and more material into the center, and the pressure in the core eventually becomes so high that hydrogen atoms began to combine and produce helium, therefore unleashing enormous amounts of energy. Okay, our sun was born as a result, and it eventually accumulated more than 99% of the accessible matter. Further out in the disk, matter was also clumping together. These clusters collided and grew into larger and larger objects. Some of them got large enough for their gravitational pull to form them into spheres, giving rise to planets, uh, we, dwarf planets, and massive moons. Okay. We also look at the composition of the solar system. The order and arrangement of our solar system planets and other things it is attributable to how the solar system evolved. When the solar system was young, only stony material could resist the heat. As a result, the first four planets are terrestrial planets, which are the Mercury, Venus, Earth, and Mars. They are all small and have rough surfaces. Meanwhile, components we are accustomed to viewing as ice, liquid, or gas settled in the young solar system's outer regions. Gravity drew these components together, resulting in the gas giants Jupiter and Saturn, as well as the ice giant Uranus and Neptune. The Sun is home to 99.85% of all stuff in the solar system. The planets which formed from the same disk of material that formed the Sun account for only 0.135% of the solar system's mass. Jupiter has more matter than all the other planets combined, okay? So the list below shows the mass distribution of our solar system. Sun, we have the Sun, planets, comets, satellites, minor planets, meteorites, and interplanetary medium with their volumes as you can see on your screen. By volume, nearly the entire solar system appears to be an empty nothingness. This vacuum of space is not emptiness, it is the interplanetary medium. It contains many types of energy as well as at least two solid components, which is interplanetary dust and interplanetary gas. Microscopic solid particles make up interplanetary dust, and the solar wind is a tenuous flow of gas and charged particles, principally protons and electrons, plasma that stream from the sun. Other objects in the solar system, we have the asteroids, meteorites, and satellites. So under the asteroids are rocky and metallic objects that orbit the sun but aren't large enough to be termed planets. They're called minor planets. So the majority of the asteroids in our solar system orbit the sun between Mars and Jupiter's orbit. The asteroids belt is a term used to describe this region. So the asteroid belt is a donut-shaped cluster of asteroids orbiting the sun between Mars and Jupiter's orbits closer to Mars orbits. So meteorites, aside from the asteroids, the sun is orbited by smaller rocks and dust particles. These particles of rock or dust make their way into the atmosphere and they came into contact with a lot of friction as they pass, which causes them to heat up and burn out. So a meteorite is a piece of debris that collides with the earth, and when it collides with the ground, it can create a hole or crater, and the hole gets bigger as the meteorite gets bigger. So lastly, we have satellite, and satellites are celestial objects that orbit planets and are part of the solar system. The moon is the Earth's satellite, and some satellites like Ganymede are larger than Mercury and have atmospheres. So lastly, we have the sun, and our solar system large object is the sun, and it is roughly 109 times the size of the earth, and the sun has a diameter of 1392,000 kilometers, and it comprises 99.8% of the mass of the solar system. So the sun is a star with a surface temperature of 60,000 degrees Celsius, and it is largely made of hydrogen gas with a minor quantity of helium. So the sun is the solar system closest star, and it belongs to the Milky Way galaxy. Okay. So solar flares are largely a large energy burst that occur on the sun, and fast-moving particles are ejected from the sun's surface during these flares. Above the photosphere, there are two layers of gas termed as chromosphere and corona. So the Earth will be a dead sphere of rock and ice if it were not meant for the sun. So the sun warms our globe, it influences our weather and provides energy to the plant, which provides food and energy for life on Earth. So the sun's energy reaches the Earth and other planets in all directions. The planets absorb the less energy and it gets further away from the sun. So up to there. we end it.